Hello everybody, welcome to EmbeTronicX. We have started a new tutorial series for Raspberry Pi Pico. In this series, we will learn the Pico development using both C language and MicroPython. Raspberry Pi Pico has these specifications: dual-core ARM Cortex M0+, 264 KB of SRAM, 2 MB of flash, 26 multifunction GPIO pins, 3 analog inputs, 2 UART, 2 SPI, 2 I2C controllers, 16 PWM channels, 1 USB drag and drop programming temperature sensor, and many more. As this is the first part of this series, we will just see how to set up the Raspberry Pi Pico and the Windows machine for C and MicroPython. I like ESP32 and Raspberry Pi because they will be having the proper documentation for everything. They have this Getting Started with Raspberry Pi Pico document for the C and C++ development. See, they have given almost all topics. You can refer to this document anytime. I have given you the link below in the description. We have to install a few software like CMake, Toolchain, Python, etc. But I will be following the method which has been given in this repo. This will take care of everything for the C and C++ development. Go to the latest release and download this Pico Setup. I have downloaded it already. Open that package. Click Next. See, these are the applications that are going to be installed. Click Next. Select your desired destination folder and click Install. Please wait patiently until it finishes. It's done. Let's clone the repositories. Click Finish. Just refer to this README file. It has all the usage instructions. Right now, it is cloning the Pico SDK and examples. See, these are files that have been created during the setup process. In this series, I am not going to use the command line to build the code. Instead, I will be using Visual Studio Code software for our development. So, whenever you want to open the Visual Studio Code for Pico development, please open it by opening the Visual Studio Code for Pico shortcut. See, it is adding the all necessary paths. If you open from the desktop, then your build may fail. That's why we will have to open the code using that shortcut. Here we go. The Visual Studio Code has opened. Let's set the one-time configuration. Click Extension. Add nmake makefiles to CMake generator. That's all. We have configured. Now we will write a simple Blinky program to blink the LED. Select the folder where you want to write the program. Create a new file called blinky.c. We will start the programming now. Include the header file for Pico. Then start the main function. In this example, the LED is connected to the GP13. You can use the onboard LED also, which is connected to GP25. Initialize the GPIO pin 13. And set the direction as a output as we are going to blink the LED. Then start the infinite loop and blink the LED with a 1 second interval. Now our code is ready. We have to create another file called cmakelist.txt. Just copy paste the content of the file from our Git repo. This file will be same for most of the programs. You have to change the file name here based on your project. That's it. Let's build the program. Click the No Kit selected and select the GCC ARM toolchain. If you can't able to see the No Kit selected, please close the Visual Studio Code and reopen it with a shortcut. Now click the Build. It's done. Check the generated files. Blink.uf2 file is generated. Before we flash, we will discuss about the connections. This is the hardware connection that we are using for this tutorial. This is the Raspberry Pi Pico. This is the reset button and this is the boot cell button. This LED is connected to GP13 via resistor. Every time while flashing the program, I don't want to unplug and plug the board. That's why I have added this reset button. One end of the switch is connected to the ground and another end of the switch is connected to the run pin. When we press this button, it will reset the Pico. The soft boot cell button has been broken off by my hard hand. Whenever I want to go to boot mode, I will touch the one end of the switch to the TP6 and press that switch. This is all about the connection. Now we have to flash this file. Copy that file. Press the boot cell button and press the reset button. The RPI RP2 mass storage will open. Paste that blink.uf2 file here. It will automatically close and the program will run. See, the LED is blinking in a 1 second interval. Okay, we have developed the C program to blink the LED. Now we will see how to set up the MicroPython and blink the same LED. Go to tony.org and download the Windows software. Install the downloaded software. We have installed the software. Let's open it. Let it be the initial settings and click the Let's Go. Then click Tools, Options, go to the Interpreter tab. Select the MicroPython Raspberry Pi Pico and click OK. Now let's write our code. Import the pin library and time library. Initialize the GP13 as output. Run the infinite loop and toggle the LED with a 1 second interval. Then save the file. I am getting errors. Okay, I got it. We have to go to boot mode by pressing the boot cell button and reset button. Now let's run it. Click Install. Close this now. Restart the board. Now run the program. It is not turning off. Why? Oops, I have given 100 seconds delay. Let me change it to 1 second delay. Let's run. Got it. I hope you have learned something today. Don't worry, I won't tell you to subscribe to our YouTube channel. If the content quality is good, then obviously you will automatically subscribe to us. I have provided all the links in the below description. Please check it out. We have provided other tutorials for Linux device driver, RTOS, STM32, unit testing, bootloader and etc. Please check that too. I will see you with another good tutorial. Thank you.